That is
Interference.
that is interference. That is physical meaning of interference. Now, if I start with the optical meaning of interference is, then I know that in optics we consider आपने ray optics पढ़ी है. You know the basic of ray. Ray maths में पढ़ा है ना. Ray is a line which is starting from a point and mentioned at the other end is the arrow, and it is fixed from this point and it moves infinitely in that direction with arrow. You can extend this infinitely to this arrow, right? So this is ray. You have studied line segment, right? Line is a line which has arrow in both the directions, so you can extend in this direction or in this direction. That's a line. But when we consider about a line segment, then line segment is this, a b. You cannot extend this. Line segment is always fixed, right? So this definition is basically mathematical definition, and I just bring this definition ray to the physics. It has a starting point and it moves on in one direction infinitely long. So this is ray, right? So we know that we consider a simple light, which normally we consider that light is, whenever we talk about the light, we are talking about the optics. Optics is the everything which we see is because of optics, right? So the optical phenomena is nothing but it is always related to light, and because of the optics we are able to see the things. In ray we have a source. Source is basically emanating a light in a form of ray. We have studied light in terms of ray, in terms of wave. Have you studied in terms of wave? Electromagnetic wave?
Yes, ma'am.
है ना, आपने इलेक्ट्रोमैग्नेटिक वेव में पढ़ा है ना, सिंपल हार्मोनिक मोशन काइंड ऑफ अ वेव. रे इज अ पेंसिल which is moving in one direction only, fixed it at one end. So if I have a source, then source is emanating a light in a ray form which is propagating in this direction. Okay. What happens when we have other source? Let's say this one is S1 and I have other source S2 which is propagating the ray which is emanating from the source S2 in this direction. So at this particular point they interfere. At this particular point they interfere. But what happens when two rays interfere? तो सिर्फ और सिर्फ जो इलेक्ट्रिसिटी और जो इंटेंसिटी मॉडिफिकेशन होता है, that happens only at this particular point, and after they cross each other path, they again becomes as they were before interfering. तो इंटरसेक्शन पॉइंट पर ही इंटेंसिटी मॉडिफाई होती है, otherwise intensity remains unchanged or the property of light remain unchanged. उससे पहले जो थी उसके बाद वही होगी, लेकिन जो मॉडिफिकेशन होगा इंटेंसिटी का वो सिर्फ और सिर्फ इस इंटरसेक्शन पॉइंट पर होगा where they interfere. And technically we call that as where they superimpose. They superimpose, right? When they impose to each other, then only the property of that ray or the light will modify, right? Suppose you have one source, one bulb in your room, you switch it on, what happens? It illuminates the room. You have second bulb. When you switch on the second bulb, you get more intensity in your room. The room is filled with more intense light, the brightness increases. If you have third source, if you switch on that, then again the intensity increases. Okay, so this is how the intensity modify, because we have three different sources. So what we get general brightness in the room increases all over. Okay, because if I have a point source, then the rays are emanating from this point source in every possible direction. If I have a cylindrical, then if let's say this one is cylindrical, so the wave which is coming out from this is particularly a cylindrical wave front. Have you studied the wave front? I just believe that you must have studied about the wave front. Wave front, wavelet,
Yes,
पढ़ा है
ma'am.
ना? And on the basis of this Huygens principle, Huygens wavefront theory पढ़ी है आप लोगों ने?
Yes, ma'am.
Good, right? So this is how the interference we talk about, right? Okay. Till now, I just mentioned about the ray behavior of a light. मैंने सिर्फ और सिर्फ direction of propagation की बात की थी. I did not mention about the properties or the terms which are involved in a light, because we have different theory, different treatment for the light. One, when we consider the light as a ray. Second one, when we consider a light as a wave. I know that the light is behaving as an electromagnetic wave, right? You must have studied that the light is EM wave, electromagnetic wave. Because when we talk about the ray, I can talk about the direction only. But the direction of what? How the intensity is traveling, how the energy is traveling, what is the energy, what form of the energy is actually traveling in that direction, right? Because when we talk about a sound, what changes? जब sound propagate करती है तो क्या change होता है? Particle disturbance or the pressure? Pressure होता है ना, sound is a longitudinal wave. तो compression or rarefaction, I just believe that you must have studied about the sound. जब sound travel करती है तो basically pressure change होता है, compression and rarefaction, and because of that quantity the sound travels in a medium. अब अगर मैं कहूँ light travel करती है, after all कौन सा ऐसा पैरामीटर है, कौन सी ऐसी क्वांटिटी है that changes, that actually propagating in that direction, and that quantity is, that energy is electric field and magnetic field. Okay, so the electric field changes, then the light travels in that particular direction. So the field which is changing along the propagation direction of the light is nothing but the electric field and magnetic field. Light is nothing if we do not have electric and magnetic field together, right? So you must have heard that light is transverse in nature, and the direction, what does that mean? The transverse in nature. When I say the sound is longitudinal in nature, it means that sound is longitudinal in nature, यानी कि जो property change हो रही है, जो physical phenomena change हो रहा है, वो in the direction of the propagation of sound में हो रहा है. So that is longitudinal. But यहाँ पे जब हम light की बात करते हैं, तो light में जो फिजिकल क्वांटिटी या जो पैरामीटर चेंज हो रहा है, जो एनर्जी चेंज हो रही है, वो परपेंडिकुलर डायरेक्शन टू द डायरेक्शन ऑफ प्रोपेगेशन चेंज हो रहा है, जिसकी वजह से लाइट प्रोपेगेट कर रही है। एंड वो दो कंपोनेंट हैं, वन इज लेट्स से इलेक्ट्रिक फील्ड एंड वेयर इट इज, one is electric field and one is magnetic field, like this, which is perpendicular to electric field and perpendicular to the direction of propagation. Okay, like this. This is how it is changing. So let's say this one is my electric field which is changing. This is amplitude, the maximum value, which let's say this one is E naught, and similarly this is magnetic field. Let's say this, I call it as H naught, the amplitude H naught. This is direction of propagation. Okay. So if I say this one is let's say X, this one is X, this is Y, this is Z. So this or the part difference X later, no? Okay, sorry. So I'll call this as X. This is Y. So the magnetic field is in Z direction. Okay, so this is how we can say. So we have, whenever we talk about a wave, we talk about the electromagnetic nature of light. Electromagnetic nature means the electric field and the magnetic field in a sinusoidal form is propagating in the direction of wave, propagation of the wave. In optics, we always talk about the electric field. We generally drop this magnetic field. This doesn't mean that the magnetic field does not exist with the electric field, because light is incomplete if I mention only electric field, right? The light, अगर हम दो component की बात कर रहे हैं, एक propagation की, एक कंपोनेंट है प्रोपेगेशन और एक कंपोनेंट है इलेक्ट्रिक फील्ड, तो इसका मतलब है जो तीसरा डायरेक्शन, नॉर्मल डायरेक्शन बचा हुआ है, वो ऑटोमेटिकली मैग्नेटिक फील्ड के लिए रिजर्व हो जाएगा. सो वी that is hidden, that is taken as obvious. So we do not talk about the magnetic field while studying about the optics. We talk about the direction of propagation and the electric field. The third axis which is remaining is automatically considered to be the magnetic field. Okay. So any wave that can be measured, or the properties of that wave can be studied, is associated with these parameters. One is wavelength and one is amplitude, frequency, because that is associated with wavelength itself, so I'm not just mentioning here, the frequency, and a very important term, that is phase, phi, phase, right? So that is again a very important. Phase is very important, because if you look at this wave, then this wave is same जो यहाँ पर थी. अगर मैं ये वाला सेक्शन कट कर दूंगी तो ये वाली वेव और ये वाली वेव एग्जैक्टली सेम है. There will not be any difference. You cannot mark any difference between this section and this second section. This first section or second section में आप कोई difference नहीं निकाल सकते. But yes, if I know the phase at this particular point, then definitely the phase at this point will be 2 pi plus phi, and phi is, let's say, the phase at this particular point. So this is how you can differentiate. अगर मुझे wave को अगर are you getting my voice?
Yes, ma'am.
Okay. If uh, where I was, yes. If you have to find out the difference at these two particular points, so wave exactly same है, उनका amplitude same है, exactly everything is same. The only thing that is varying here as the wave is propagating is phase. Okay, so this is very important, and this point onward we will more focus on phase. We talk everything in optics related to phase because that's the only point where by using which parameter we can differentiate between two waves, right? So we have a path, that the path that has been traveled by a wave for a complete, it is lambda, right? So we have a wavelength lambda. So if it travels a path that is lambda, the phase difference is 2 pi. Just as I mentioned here, at this point and this point where the additional phase is 2 pi means that in the difference between these two will be exactly equal to the path difference is lambda, right? So what happens if the beam travels only this distance? This says x, only x distance. It means that if the path difference is x, the phase difference is 2 pi by lambda into x. Okay, so anytime I can say that the phase difference is defined with this Kronecker delta equal to 2 pi by lambda into path difference, and this path difference is anything from 0 to lambda, right? So let's say if I have two waves, one is traveling in this direction like this, the second wave which starts like this at this point, right? So what is the phase difference? The phase difference between these two will be this one where they are interfering is x, and you can calculate the part difference between these two will be this much, so you can calculate the phase difference between these two waves. Okay, is that clear? Fine. Then, okay, so what happens when I mentioned the first instance that when you switch on the light of your room, the room will fill with the light, the illumination. It eliminates. But when you switch on the second source, it further eliminates. The intensity of the room or the brightness in the room increases, but you cannot actually deduce the point where it is increasing, where the intensity is being modified, because the two sources which you just switch on are not coherent. Are not coherent. What does this mean? Coherent. This term is most important while studying about interference. Coherent. Two sources are incoherent and the two sources are coherent. When we say the two sources are coherent, it means that अगर मैं उनके बीच में किसी भी दो रे को स्टडी करूंगी तो इफ टी इज इक्वल टू 0, अगर उनके बीच का फेज डिफरेंस लेट्स से 30 डिग्री है या पाई बाय व्हाट से द पाई बाय 6 रेडियन है, तो t इज इक्वल टू आफ्टर 12 सेकेंड भी उनके बीच का फेज डिफरेंस 30 डिग्री या पाई बाय 6 रेडियन ही होगा. एंड आफ्टर 30 सेकेंड्स भी उनके बीच का फेज डिफरेंस 30 डिग्री या पाई बाय 6 रेडियन ही होगा. देन the two sources are said to be coherent. But what happens when you use two sources? Okay, just tell me any vague idea, any guesswork that work, how the light produce. How do we get the light from any source? I am expecting an answer from any of you. Random answer. Atul, Anoop. हाँ जी, बताइए बच्चे. नहीं पता. How do you get the light? You get the light whenever there is energy transition of whenever there is transition from higher energy to lower energy of an electron, then what happens? How the energy released? पढ़ा है ना आपने? Yes,
When
बताइए आप.
the energy transfers from higher energy to lower.
Yes, whenever there is energy, whenever de-excitation of an electron takes place from higher energy state to lower energy stage, a form of quantized energy released, and that quantized energy is basically sometimes in a form of photon, or sometimes it may be a thermal energy. ठीक है, पढ़ा है ना ये आपने, डी एक्साइटेशन एंड एक्साइटेशन ऑफ एटम्स और द इलेक्ट्रॉन्स फ्रॉम हायर एनर्जी टू लोअर और लोअर टू हायर एनर्जी. जब लोअर एनर्जी से हायर एनर्जी पे जाता है तो जितना एनर्जी डिफरेंस होता है उसको वो एनर्जी डिफरेंस कहीं से चाहिए होता है. सो व्हाट हैपेंस, वो उस एनर्जी डिफरेंस को ग्रैब करता है either in a form of the incident photon or in the form of some kind of energy. It can be heat energy, it can be vibrational energy, or any sort of energy. But the equal amount of energy. So, because the energy is quantized, when I say quantized, it means that the energy must be fixed. 1, 2, 3, and so on. It cannot be like in 1.2 or 1.3. It must be either 1 or 2. So the energy is quantized. Photons, when we talk about photons, photons is basically quanta. Right? When we say the photons, photons is nothing but the quantized energy. Right? And the energy, the photon must have some quantized energy in form of h nu, and h nu, this nu is the frequency of light which you are getting. Okay. So when I say that, क्योंकि अगर दो sources हैं तो मैंने एक source on किया, I just switched on one light, what happens? Excitation and de-excitation of atoms starts taking place, right? So, and light सिर्फ एक photon से नहीं आती. When you get a light source, though वो light source सिर्फ एक photon से नहीं आता, that the light you must get with a bundle of photons, the trillions and zillions of photons exactly taking place, excited or de-excited from higher energy to lower energy at one time. And they follow a batch. एक साथ बहुत सारे एटम्स de-excite होते हैं, at the same time कुछ atoms excite भी होते हैं, so that they can further get de-excited, and this is how you get a continuous light from any light source. अगर दो light sources हैं तो we cannot control all the atoms to get excite and de-excite at the same time. The batch will de-excite at different time. तो उससे क्या होगा, जो वेव होगी, जो वेव जनरेट होगी उस सोर्स से, वो रैंडमली किसी भी टाइम होगी. तो अगर मैं t इज इक्वल टू 0 टाइम पे दो सोर्सेस के बीच का फेज डिफरेंस मेजर करूंगी तो दे मे 30 डिग्री But after 12 seconds, it is not necessary that there will be a phase difference of 30 degree again. So they are not synchronized, they are not coherent. The two sources, two independent sources are not coherent, क्योंकि उन दोनों के बीच में जो फेज डिफरेंस है वो टाइम के साथ चेंज होता रहेगा. दे विल नॉट हैव अ कांस्टेंट फेज डिफरेंस. प्लीज टेक केयर व्हेन आई से कोहेरेंट. कोहेरेंट का मीन्स है कांस्टेंट फेज डिफरेंस. यानी कि अगर पाई बाय 3 पाई बाय 6 रेडियन का फेज डिफरेंस है तो वो थ्रू आउट द प्रोसेस पाई बाय 6 का फेज डिफरेंस रहेगा. ठीक है. चाहे अब अगर मैं दो सोर्सेज प्रोड्यूस करूं एज अ डॉटर सोर्स फ्रॉम अ सिंगल पेरेंट सोर्स, एक सोर्स है, उसी सोर्स में से मैं दो सोर्सेज प्रोड्यूस करूं S1 एंड S2, राइट. अब क्या होगा कि इस सोर्स में से मैंने आपको बताया वी हैव अ बैचेस. ठीक है. एक बैच एक टाइम पे फोटॉन्स जनरेट करेगा, एट द सेम नेक्स्ट टाइम क्या होगा, दूसरा बैच जनरेट करेगा. सो बेसिकली अगर इस वाले सोर्स की वेव की मैं बात करूं तो ये अगर ऐसे आएगा और सपोज आफ्टर सर्टेन टाइम ये ऐसे आता है, आफ्टर सर्टेन टाइम ये इस तरीके से हो जाता है, तो क्या होगा, यहाँ पे कंटिन्यूटी ब्रेक तो होगी, फेज चेंज होगा, लेकिन जब इसका फेज चेंज होगा ऑटोमेटिकली इसका और इसका भी फेज चेंज हो जाएगा. तो इन दोनों के बीच में जो फेज डिफरेंस रहेगा वो हमेशा कांस्टेंट रहेगा. चाहे यहाँ पे पहले फेज सपोज 30 डिग्री था इनिशियल फेज, बाद में 60 डिग्री हो गया, उसके बाद 20 डिग्री हो गया, फिर 10 डिग्री हो गया, फिर चाहे 70 डिग्री हो गया, लेकिन इन दोनों के बीच का फेज डिफरेंस हमेशा 30 डिग्री रहेगा, क्योंकि ये दोनों सोर्सेस इस सोर्स से जनरेट हुए हैं. तो अगर इसमें चेंज होगा तो दोनों में ऑटोमेटिकली उसी टाइम पे चेंज हो जाएगा. पर क्योंकि पार्ट डिफरेंस दोनों का अलग अलग है तो दोनों के बीच में इनकी वजह से, इस पाथ की वजह से फेज डिफरेंस इंट्रोड्यूस रहेगा, एंड हेंस दैट phase difference will remain constant. So the sources are said to be coherent sources. Question एग्जाम में एक क्वेश्चन जरूर आता है, just to check your basics, why the two different sources cannot be a coherent source. ये क्वेश्चन फेवरेट क्वेश्चन होता है एग्जामिनर का, just to verify your basic knowledge that how can you define, how can you connect a coherent source with the interference. And the question 90% is why two, or state the reason why two independent sources cannot be a coherent source. The reason is उनके बीच में जो light wave produce होती है they cannot be controlled. So basically two different sources cannot be coherent sources. Okay, now अब हमें जब when you switch on the light of a room आपको इंटरफेरेंस मिलता है, लेकिन आप उस इंटरफेरेंस को पर्टिकुलरली ऑब्जर्व नहीं कर पाते हो. When I say observe, right? So जब ऑब्जर्वेशन की बात आती है तो आपको याद है या कभी आपने नोटिस किया है when do you observe the interference? लास्ट आपको याद है आपने कभी इंटरफेरेंस ऑब्जर्व किया हो इन योर डेली लाइफ? यस, नहीं याद. ओके, अब करना. व्हेन you must have I do not know about the weather must be cold out there, है ना? Almost similar weather.
ठंडी है,
Okay.
ठंडी बहुत ठंडी.
ठंडी, हाँ बहुत ठंडी है. ओके ओके, नो इश्यूज, यहाँ भी बहुत ठंडी है. ओके, सो क्या होता है व्हेन यू टेक बाथ इन समर्स, यू टेक लेजर बाथ, है ना? सर्दियों में तो जल्दी जल्दी नहाते हो, बट व्हेन यू टेक बाथ इन समर्स यू टेक अ लेजर बाथ. और जब आप आराम से नहाते हो तब आप सोप बबल्स बनाते हो. Then you must have observed beautiful colors in a soap film. Is it? देखा है कभी
Yes, ma'am.
ध्यान दिया है? Yes.
Yes, ma'am.
तो वो beautiful colors कैसे मिलते हैं? That is because of interference. क्योंकि you use white light source in your washroom, in your bathroom, then what happens? That beautiful the colors which you observe out of this thin soap film is due to constructive interference, or I'm just dropping this constructive, due to interference of that particular color. आपको अगर रेड कलर मिल रहा है यानी कि इस समय रेड कलर डोमिनेट कर रहा है, वो कंस्ट्रक्ट हो रहा है. अगर आपको ब्लू कलर मिल रहा है तो यानी कि ब्लू कलर कंस्ट्रक्ट हो रहा है आउट ऑफ व्हाइट लाइट. सारे कलर्स कंस्ट्रक्ट नहीं हो रहे हैं वहां पे, ब्लू कलर कंस्ट्रक्ट हो रहा है, रेड कलर, येलो कलर, इस तरीके के डिफरेंट कलर्स आर कंस्ट्रक्टिंग. And what happens in winters also, if you apply oil massage before taking bath, जब आप गर्म पानी से नहा चुके होते हो, then you must observe a thin oil film on the floor, and if you observe that carefully, then what happens? You observe different colors in that thin oil film which is floating on the surface of a water. Or this kind of interference you can observe in a rainy season also, when some oil leaks out from any vehicle, और जब वो रोड पे वाटर जो पिट होल्स होते हैं उनमें थोड़ा सा वाटर जमा हो जाता है, and suppose some oil drops in that water, so when sunlight उस पे strike करती है, then you observe a different colors, and that different color is basically due to interference. Okay, so it means that what we are talking about, that we are talking about the interaction of waves emerging from the same source or the same frequency of these waves which are actually coming out from the source which is coherent. Okay, so अगर मैं लाइट की बात करूं तो in the context of light, which is an electromagnetic wave, we can say that when the light from the two different sources moves in the same direction, then these wave trains or light wave trains superimpose upon each other. As a result, modification of distribution of intensity of light takes place. Okay, so according to the principle of superposition, this is called the interference of light. Okay, if I define interference more precisely, then I can say that the interaction between two or more waves of the same or approximately same frequencies emitted from the coherent sources where the wavefronts are combined according to the principle of superposition. So this is a very technical definition of interference. Okay, so the things will be more clear as we proceed in this direction of interference. As we move deeper and deeper into this unit, the things will be more clear. Right, so before concluding the class, let me mention you about the how you get the coherent sources. क्योंकि मैंने आपको ये तो बता दिया how we cannot get the coherent sources. We cannot get the coherent sources just by using two different sources. Now the question is, अगर दो different sources से मुझे coherent source नहीं मिल सकता, then how do we get the coherent source? The coherent source will be obtained by the division of the wavefront and by the division of the amplitude, or in a way intensity. right? So the division of wavefront is being obtained by Young's double slit or the Lloyd mirror. Lloyd mirror is not in your course, but I just mention it for the example. Young's double slit is very much in the course, and the division of amplitude is thin film interference, which I just mentioned. कि आप soap bubble देखते हो या thin oil film देखते हो, then you get the interference. That is because of the division of amplitude is taking place. Light एक ही source से आ रही है, but they are getting divided into two or more waves, and when they interfere, when they superimpose, some particular wavelengths sum up as a constructive wavefront. So basically, as a result, we can observe the intensity of those particular colors. तो हमें beautiful color fringes, color दोनों एक ही सोर्स से आई हैं, therefore they must be coherent, right? And the Lloyd mirror is like this. एक मिरर लेते हैं, उसके जस्ट ज्यादा ऊपर नहीं, समवेयर हेयर एक सोर्स रखते हैं, दूसरे सोर्स की इमेज बनती है. सो बेसिकली since we are using mirror, so the intensity remains unchanged but the wavefront divided. Okay, so we have two examples for the coherent sources is division of wavefront, and an example from the division of amplitude, a thin film. You know that, let's say I have a source here, the light or the ray falls on this surface, partly transmitted, partly transmitted and partly reflected. So the amplitude distributed and hence decreases further from the lower section, the lower part of the thin film, it partly reflected and partly transmitted. So I'm not considering this right now. So this is further reduces. When it moves in this direction, it again comes back here, partly reflected and partly transmitted. So basically the intensity of first and the second ray, which are otherwise moving in the same direction, but their amplitude or the intensity are not same. So what we did, we divide the amplitude, right? Sorry, we divide the amplitude, पर क्योंकि दोनों रेज सेम सोर्स से आई हैं, इसीलिए दोनों कोहेरेंट हैं, लेकिन उनके एम्पलीट्यूड्स इंटेंसिटीज इक्वल नहीं है. Okay, so with this note, I stop my class at this particular point. You just study about the topics like coherent source, incoherent sources, interference of the two or more waves. ठीक है, it's a high
मैम
time you. हाँ जी,
ये पीपीटी हमको कब मिलेगा?
ये पीपीटी आपको जब आप बोलोगे तब मिल जाएगा. अभी तो मैंने सिर्फ 2 ही पेज इसके कंप्लीट किए हैं. आप बताओ
इतना
कब
ही
आपको दूं. हाँ बच्चे.
इतना ही प्रोवाइड कर देना हमको.
हाँ श्योर श्योर, यू विल गेट दिस. एंड
ओके मैम.
हाँ जी, और बताइए. That's it.
यस मैम.
Okay. Are you able to follow what I am just talking about in this lecture?
यस मैम, लिटिल बिट.
A little bit. Okay. Okay. You just go through this